So we're gonna work on what we call discrete probability distribution. What is it first? Okay, when you say discrete probability distribution, it can be in the form of table, it can be in the form of graph. However, what is it? So it provides possible values of the random variable x. So the random variable x can be either a price, a value, either of winning or losing, or certain values that might be applicable for considering cases and their corresponding probabilities. And there are two considerations for a discrete probability distribution. The first one is that the summation, right, the sum of all the probabilities of all the events, okay, all the outcomes should be equal to 1. Okay, so if you add them all up, all the probabilities, it should be equal to 1. And also that the probability will always be what? From 0 to 1. Okay, 0 being impossible, 1 being certain that's going to happen, and it depends on whether it's going to be unusually going to happen or usually going to happen depending on the value. Now, let us consider first some cases in here and see what we can do about them, okay? Angelina, let's read problem 5 in here and how we can work on that one, okay? Determine. Let's do the instructions first.
Determine whether the random variable is discrete or continuous. In each case, state the possible values of the random variable.
Thank you. All right, let's read letter A. Tiff, go ahead, please. The number of
light bulbs that burn out in the next week in a room with 20 bulbs.
Thank you. Okay, so that one, it says what? The number of light bulbs that will burn out. So is it discrete or continuous?
Discrete.
Discrete. Thank you, right? Because when you say number of light bulbs can be what? 0, no light bulb at all, that will be busted or burn out. Or there can be like what? 19 of them or 15 of them. So these are all what? Integers. You cannot say, well, there are like 15.6 bulbs. Discrete, so that means it's always going to be integer value. Okay, that's correct. As you may notice in here, x is from 0 to 20 bulbs out of 20, okay? Let's read letter B. Robbie, go ahead, please.
The time it takes to fly from New York City to Los Angeles.
Thank you. What do you think about that one, Robbie? Continuous or discrete? When you talk about time, like estimated time of arrival, or what we call ETA.
Discrete? Or
It's basically, well, it's basically continuous simply because when you go there, when you arrive there, then you can compute in here, whether that be in terms of what? Hours, minutes, seconds, and even milliseconds, all right? So you have those, minimal categories in there of time that you can consider other than the minutes or the hours. Get it, guys? So with that being said, then it is what? Continuous. So when you say from New York to, let's say from here, from say, what's the nearest airport? Either Charlotte or what? Asheville, right? Going to New York. How long will it take? Anyone in here who have flown from here, say the Charlotte Douglas Airport going to New York? How much will be your flight time usually? Anyone? Not yet? Okay. Well,
About 2:45 maybe.
2.5
2.45
hours. Yep. Typically, you are within that time frame, okay? Because I have flown, I think 2 years ago, from here to New York, because most of my families are in New York and New Jersey area. And
It's an hour and 40.
It's an hour 40.
there we go. Very good, right? Typically, an hour 40 minutes. In my case, that time is basically 1 hour 30 minutes. So that 10-minute time frame, it depends on the air traffic, whether you're gonna be on air already or just gonna be, waiting for your airplane's turn to be flying out on the tarmac. Okay, but yes, 1 hour 40 minutes is the typical case. But usually, what they report in there when you say 1 hour 40 minutes, typically on a good day, it'll be shorter than that. In my case, during my time, it's 1 hour 30 minutes, and it can be a delayed flight as well, so which is gonna add up to your time. But anyway, what you mean is it's still continuous. Okay. Next one in here, letter C. Let's read letter C in here. Caroline, please. Right. The number of.
Number of hits to a website.
Thank you. Right. Number of hits. So therefore, when you say number of hits, you can say what? 0 hits. Sometimes views as well, right? Or sometimes comments as well, or sometimes likes as well. Okay. So yes, these are what? Discrete or continuous? Discrete. Okay. And the last one in here. Letter D. Emma, go ahead, please.
The amount of snow in Toronto during the winter.
The amount of snow in a certain place, in this case, Toronto, during the winter. Is it discrete or continuous, guys?
Continuous.
Continuous. Okay, very good, right? Because you're talking about inches of snow, but definitely you can say like, well, it's like, on a blizzard, usually it's like what? More than 6 inches of snow, right? So let's say what? 6.7 inches of snow in reality, okay? So there's like those decimal equivalents that will make it continuous. Questions with number 5? Okay, so just basically determining whether it is continuous or discrete. Okay, last one in here. Numbers 9, 10, and 11. Let's read the instruction for such. Kalina, go ahead, please. Determine whether. Numbers 9, 10, and 11. Okay. Let me just read it for you guys. Right? Determine whether the distribution is a discrete probability distribution. If not, state why. Okay. So first of all, look at the x values. Are they all discrete numbers? They're all integers, right? 1, 2, 3, 4. 1, 2, 3, 4. 10, 20, 30, 40, right? There's no decimal value, so yes, it is discrete. Now, what is the next consideration? We have 2 considerations in here, okay? The first one, that the sum of the probabilities is equal to 1 if you add them all up, all the p's. And also, any of those probabilities should be from 0 to 1 only. It cannot be negative, it cannot be more than 1, okay? So which among these is not a discrete probability distribution? As you may notice,
11
number
is
11 is not. Why? Look at that. Very good, right? You see that one? Since that is negative, then that means that will make this one not a discrete probability distribution. Once again, your probability of any event should be what? 0 to 1. Okay, less than 1, but still non-negative. Questions? What about these other 2? Are they discrete? Well, yes, all of those are less than 1 but positive. Now let's add them up. What's the sum in here of the probabilities? Sum of the p's. 0.2, 0.2, 0.2, 0.2, 0.2. Add them all up is equal to 1. Very good, Liana. What about this? Let's count all of the probabilities in there. 0.5, 0.1, 0.1. All right, that's 0.7 and that's 0.3. That's 1, definitely. Yes, so basically this 2 is what? A discrete probability distribution. Once again, there are 2 conditions. First, that the sum of the probabilities will equate to 1. And second, that there is no probability less than 1. Negative or more than 1. Okay? Questions, guys? Now, let us consider one particular problem in here to work on for now and see how we can work on this one. Okay, so here it is.
Now you said negatives would mean it's not probability. Is that for 0 also?
Your probability can be 0. That means, that's a good question, OB. Your probability can also be equal to 0. That only means that that event is impossible. It cannot happen at any condition. But yes, the probability can be 0 as well. However, it cannot be negative. It can also be 1 if in any condition it will always happen. Questions? Now, let's read it here. Number 26, our what we call life insurance. Okay, and that will be the inspiration for our project, definitely. Let's read this one first. JC, go ahead, please. A life insurance company.
A life insurance company sells a $250,000 term life insurance policy to a 20-year-old male for $150. According to the National Vital Statistics Report, 58, parentheses, 21, the probability that the male survives the year is 0.09. Compute and interpret the expected value of the policy to the insurance company.
Thank you. Okay, so in this case, we're going to consider an expected value or random discrete probability distribution for such. So here it is. I'm going to consider now a table of values for this case. This is the x and this is the probability of x. Now, there are only 2 events for that. And what are those 2 events? For this 20-year-old male. The 2 events is that one. First, he lives, okay, to celebrate his 21st birthday. Okay, that means he survives 1 year. Okay, 1 more year. Okay, either he lives or he expires. All right, or die. Honestly, right? But typically for insurance cases, they call it expire. Okay, or mortality rate. Okay. Next, the X will be the what? The amount that your beneficiaries is gonna what? Gain or lose on any of those 2 scenarios, right? So these are what we call what? The values. Okay. So let's take the case if the person, 20-year-old male, lives to his 21st birthday, then that means in terms of values, what will happen to the $350 that he actually cashed out as a premium for that insurance? Is he gonna get it back or he's gonna lose it? Again, you paid $350 on your 20th birthday or 20th year, right? With the assumption that if you don't make it to the 21st year, then you're gonna get how much? $250,000, right? But since you live another year, what's gonna happen to the $350?
I'm gonna lose it.
You lose it already, okay? Get it? Okay. So in here, what's your value in here? Negative $350. Okay. Now, however, if this person didn't make it to the 21st birthday, then how much will his beneficiaries gonna have? 250,000, right? So his beneficiaries is gonna have what? $250,000. By the way, less than the what? The $350 that he actually paid for the insurance policy. Okay? So he's not gonna get back the $350 anymore. However, definitely his beneficiaries is gonna get $250,000. But again, since you already paid the $350, then you're gonna less it from the $250,000. Get it? Okay. Next, what is the probability? What do you think is the probability that he will live another year? What did it say? Yeah, that's the survival rate, right? So that's what? Still really high, definitely, right? Point, what's that? 998,734. Okay. What do you think then is the probability that he will expire or, unfortunately not live for the next year?
Complement of that.
The complement, very good. So what do you do with this to get its complement, Mason?
Minus.
1 minus, very good, right? So I'm gonna put in here 1 minus 0.998734. Okay, so that's our first step for such. They put in here step number 1. Make a discrete probability distribution table. Okay, so that's our probability distribution table. It has its own x, the values or the events, and p, the probability of each event. Okay, once again, it must be to consideration that any probability in here should be less than 1 and non-negative, and it's also, if you add them up, that's also equal to 1. Okay. Second step, number 2. What do? Here it is, right? Okay, so let's read that one in here. Mason, can you read from here? Step number 2.
Compute each x
Times.
times the probability of x.
Thank you, right? So you see the x and its probability, you multiply them together, okay? So in here, what's that gonna be in this case, okay? So for the first one, let's put it in here, okay? X times p of x, right? So for the first one, for the live, what's that gonna be? Multiply 350, negative 350 by 0.998734. On our calculator, what's that gonna be? Okay, negative $350, right, times the probability of survival to the next year, 0.998734. How much did you get, guys? For the live. This times that. X times px. What you got? Oh, calculator. Okay, so please verify. I got the following: $349 and 5569. Okay.
Yeah, that's what I got.
Okay, thank you. Again, that's negative simply because if he lives another year, then he's losing the $350 premium. Okay. Next one, I'm gonna multiply this by that. That is if he expires. All right. So expires or pass away. Right. So what's that gonna be? 250,000 minus what he paid for, the insurance premium, 350. Multiply it by, what's that? 1 minus 0.998734. So just be careful with the typing in the numbers, okay? Those are a lot of numbers, so be careful with that, okay? Those are what we call manual errors. Anyway, what did we get? Verify. On my end, I got the following: $316 and 0569. Okay, get the same value, guys. Okay, so again, just be careful with those numbers, putting them in. And step number 3, here it is. Okay. Okay, Angelina, can you see it from here? Get
Get the summation of x times p of x.
Thank you, right? So whatever XP of excess you got, those products, you add them up, okay? So let me color this red. Adding them up, then that means your X, PX summations in here will be equivalent to how much? So I'm gonna add them all up, these two, what's that gonna be, okay? Okay. So make sure you use your calculators for this, guys. How much did you get? verify. I got on my end.
Yeah,
You got the same?
yes, sir.
Yep, that's negative $33.50. Okay, so what does it mean? And that is our step number 4, the last step, okay? OB, let's read this one. Step number 4, the last step.
Interpret the expected value.
All right, so what does it mean when you say negative $33.50? Who is on the losing end? Who is losing $33.50? And who is gaining the $33.50? Sydney?
Oh, you are?
Huh?
Wait, you talking about the fucking?
Yeah, this $33.50. It's negative, right?
We are, right?
Huh?
We are, right?
We are losing the $33.50.
And the company is gaining.
And the company is gaining how much? $33.50 from that insurance policy. Are we good? Alright, so that means this one, this expected value is what? The insurance company profits how much? By $33.50
Good question.
per client. Okay, go ahead. Yes.
Could you get that number in the green, step 2, I think?
Step number 2. Compute each x times P of x's. Yes.
Or step 3, actually.
Huh? Step number 3. Summation of x P of x. So what we did in here, when you say summation, since we only have 2 products of x P of x, so by the way, this times that is equal to this. This times that is equal to this. Okay? Now, if you add them all up, these 2 xp of x's, if we add them all up, that's a summation, it turned out to be negative 33.50. Now, what does that mean? Who is gaining and who is losing? Well, the client is losing $33.50 for this insurance policy. Okay? That's the risk taken by the client. Okay? However, the insurance company definitely, you are the insurance company, you want to gain profit out of it, right? And how much is he gaining per insurance policy? $33.50. Get it, guys? Okay. So again, the expected value in here is much important, and definitely this is the way actuarial sciences actually makes what? Insurance coverage policies to consider like how much profit are we gaining from this, and definitely the clients would want to be involved in this one as well, because I mean, who knows what's gonna happen in the future, right? At least some of your dependents is still gonna have, you know, something to consider, right? If in case something's happening. And that's the same with property liability insurance, car liability insurances, and all insurance policies. You have to consider the risks that, you know, clients are gonna be into, and considering these risks and probabilities and putting a price on that. Get it? Okay. Questions, guys, with what we did? So yeah, let's cut it off for now. Thank you.